Good morning, everyone. Yeah, myself, Priya RK, and I am a top educator in the category of EAMCET. I have been teaching on an academy platform from last 4 months, and in the offline mode, I also teach for JEE, NEET, and also CET category from last 4 years. Yeah, good morning, Shafakat. Thank you for joining. So this is about the plus subscription. There is 3 different plans in this plus subscription. You have a 12-month plan, which is about 12,375 rupees, and there is a 6-month plan, which is about 10,125, and also there is a trial price, which is about 2,250 rupees, and this trial price is only applicable for the new subscribers. Okay, so if you want to have a 10% off on this any of these subscription plans, you can use the code PRKLIVE. If you use this code PRKLIVE, you will be getting 10% off on any of these plus subscription plans. Okay. Good morning, Sunil. Good morning, Sachita. Please attend your regular classes. Yeah. So if you want to use any of this plus subscription, please use this code PRKLIVE. And the question arises, why we need to go for plus subscription when we are getting free classes, right? So here in plus subscription, you will be getting premium content at very affordable price, and there will be live courses, doubt clearing sessions. Quiz will be organized at regular intervals for self assessment, and there will be separate batch for complete preparation of each and every examination, and a test series will be conducted. DPPs will be given, daily practice paper. Mock test will be conducted at regular intervals. And under single subscription, you can have unlimited access to the content on Unacademy platform. So please join this Unacademy Plus subscription plan. Good morning, Pradeep. Thank you for joining. Yeah, so we have been studying electrochemistry chapter since the start of these YouTube classes, and every class we are taking a certain part of this particular chapter so that it is helpful for you people to revise and understand. The complete guide for this chapter is available on my profile on Unacademy. So you can go to my profile on Unacademy to have the complete access on this particular chapter, including JEE, NEET, and CET questions are being solved on that platform. And here also we are going to start solving certain questions. Okay, yeah. So till last class we have studied about Gibbs free energy. Problems on Gibbs free energy has been solved. Also we have solved certain questions, previous year appeared questions on equilibrium constant, and also the other topic, that is Nernst equation, that is calculation of the cell potential, right? On cell potential also we have solved many of the questions, right? Next, let us go for the next topic, that is conductance of electrolytic solution. Conductance of electrolytic solutions. So electrolyte is any substance that has ions in it. Okay, and we know there are two conditions for conduction of electricity, and those two conditions are nothing but, first one is presence of ions should be there, or else either there should be presence of uh, electrons, free electrons. Good morning, Prajwal. Good morning, Shweta. Very good morning, Gaudappa. Yes, so this conductance is shown by some electrolytic solutions. Almost all the electrolytic solution, they show the conductance. So before going into the conductance, so whenever electricity is conductant, definitely there is some obstacles, right? There are certain obstacles. So that obstacles, we usually call it as resistance. Okay, the resistance is nothing but the not allowing of electricity to pass properly. Okay, so some of the substances, they do not allow, due to certain conditions, they do not allow the electricity to pass properly, and that we call it as nothing but resistance. Okay, and the resistance is represented by R. Resistance is not proper allow of passing of electricity. So resistance is represented as R. Now this resistance is completely dependent on two different factors. One is the length of the wire and cross-sectional area. Cross-sectional area and length of the wire. Now this resistance is directly proportional to length of the wire and inversely proportional to cross-section area. Inversely proportional to cross-section area. For example, what does this mean is, if the length of the wire increases, resistance increases, means electricity will not flow properly. If cross-sectional area increases, resistance decreases. Resistance decreases means current can flow easily, right? So if length increases of the wire, current doesn't flow properly, and if cross-sectional area increases, then resistance decreases. This proportionality symbol can be removed by placing a constant, and this constant is nothing but your rho L by A. Okay, this rho is nothing but resistivity. This rho, RHO, this is called as rho, and this is nothing but resistivity. Resistivity. Okay, a constant for resistance is called as resistivity, or else it is also called as specific resistance. It is also called as specific resistance. Yeah, right. Now coming to the SI unit of this particular component. Okay, now you know that length, it can be measured in terms of meters, and this area, it can be measured in different terms. Like area we usually represented as different terms, like, so the basic unit for resistance, right? The basic unit for resistance is ohm. It is nothing but represented as ohm. This is the symbol for ohm. So SI unit for resistance is ohm. And now coming to the proportionality constant rho. Coming to the proportionality constant rho, which is also known as resistivity. Okay, resistivity. Its SI unit R. The SI unit of rho is nothing but ohm meter. Ohm meter. SI unit of resistivity is nothing but ohm meter. Okay, now it can be also in terms of centimeter, like ohm centimeter also, right? But SI unit is ohm meter. Now let me see any other comments are there. Good morning Shrishel, good morning Sanjana, welcome Aparna, good morning Chaitra. Thank you everyone for joining. You can attend your regular classes. Okay, now there is one more term, that is, now this is resistance. Okay, this is resistance. The inverse of resistance is called as conductance. Definitely resistance is opposite of conductance. Conductance is flow of electricity. Resistance is stoppage of that flow of electricity, right? So conductance can be measured in terms of resistance also. So conductance, it is usually represented by G. Conductance is inverse of resistance. Conductance is inverse of resistance. Resistance is what? Rho into L upon A. Correct? But it is 1 upon R. So this is nothing but, if you write this, it can be written as a rho into L upon A. Right? But this is 1 upon R. So 1 upon R, if I write 1 upon rho upon L upon A. So this would be, this A will come to the numerator, A upon rho into L. A upon rho. Now this 1 by rho is nothing but your K. Now what is this K? This K is nothing but your conductivity or kappa. This K is nothing but your conductivity or also known as kappa. Right? So inverse of resistivity is conductivity in 1 upon rho. Rho is nothing but resistivity. Inverse of resistance is conductance. Inverse of resistivity is conductivity. So this 1 upon rho, I can write it as K A upon L, because 1 upon rho is nothing but K. Okay. Now coming to the units. Okay. Now G, that is conductance, is inverse of resistance. Resistance has a unit of ohm. That means I can write it as 1 upon ohm. 1 upon ohm. Ohm, if I bring it to the numerator, it will be ohm inverse. So conductance has a unit of ohm inverse. Ohm inverse, it can be written in 3 different ways. You can write it in this way, or else ohm inverse can be written as mho. Just reverse this, MHO. Okay, MHO. This is also one way of writing it. Likewise, if you go for the unit of conductivity, conductivity or kappa, or even also known as specific conductance. This is known as specific resistance. Likewise, this is known as specific conductance. It is known as specific conductance. Specific conductance has different unit. Okay, so this ohm inverse can also be called as Siemens. Okay, ohm inverse is also called as Siemens, which is represented as S. These are different terms which can be used. Likewise, resistance has a unit ohm, so conductance is inverse of that, so ohm inverse. Resistivity is inverse of conductivity, therefore this will be ohm inverse meter inverse. Ohm inverse meter inverse can be written. So conductivity has a unit of ohm inverse meter inverse, or can be written as ohm inverse, can be also written as Siemens. So I can write this as Siemens inverse also. I can write it as Siemens inverse as well. So units are simple. If you remember the unit of resistance and specific resistance or resistivity, you can write the units for conductance and conductivity because they are inverse of each other. Right? Fine. Let's just see any comments from different students. Good morning, Bhagyashri, Pranjal. Good morning, Prasad. Thank you for joining. Please stay tuned. You can follow me on Unacademy. The link to my profile, you can find it in the description box of this particular video. Please go to Unacademy and watch my different classes that I take up. The complete guide for this particular chapter is also available on my profile. So please go to the description box of this particular video and search for the link to my profile. Good morning, Palesh. So let's just move on. Okay. Fine. Now there are different components on which the conductance is dependent. Conductance of any particular solution. Conductance of solution depends on different factors. Okay. So what are those factors? Let us just discuss one by one. First one, the nature and structure of the metal. First one, the nature and structure of metal. So this factor which decides the conductance of any particular metal. It's not solution, it's metal. Let me just make a correction. Because metals have ions, and once they form ions, definitely there'll be formation of electrons also. So whether that metal is going to release the electron or no, depending on that, it is going to decide the conductance. Okay. Then second one, the number of valence electrons This plays a major role. If the number of valence electrons are greater, then number of movable electrons or mobile electrons will be more. If number of mobile electrons are more, definitely conductance will be more. So number of valence electrons per atom. Per atom. Third one, temperature. Temperature of that particular condition which we are using. So conductance C decreases with increase in temperature. Conductance decrease with increase in temperature. Why? Because once you increase the temperature, what happens is the electrons will enter from one end and it will move out from the other end. Therefore, what happens is there will be no proper conduction once you increase the temperature. Okay. So just let me see if any student has joined. Okay. Next is conductivity of any electrolytic solution or ionic solution. Conductivity of any electrolytic solution or ionic solution. Conductivity of electrolytic or ionic solution also depends on many different factors. Okay, it also depends on many different factors. For example, the first one, the nature of electrolyte added. The nature of electrolyte added. So easily dissociable electrolytes will conduct faster. Then size of ions. Once the electrolyte is there, like for example NaCl, Na plus and Cl minus. So size of ions that are formed also decides the conduction. Size of ions. Next one, nature of solvent means its viscosity. Nature of solvent and its viscosity. Viscosity is resistant to flow. For example, if you take water and oil, we say oil is more viscous because viscosity is nothing but resistance to flow. So if you just observe oil, it will not flow that easily as compared to water. So if viscosity is less, then definitely it will conduct proper electricity. Then concentration of electrolyte. Concentration of the electrolyte. This also plays a major role. Then temperature. Now here, as temperature increases, the movement of ions will be more. Therefore, conductivity K increases. Right? Conductivity K increases. So these are the two conditions wherein we study more about the conductance of metals, on what factor it depends, and conductivity of electrolytic solution. Right? Okay. So these are the two things very important. Next one. Measurement of conductivity of any ionic solution can be done by a particular method. So what is that method? So let us study now. So measurement of the conductivity of, how to measure this? Okay, conductivity of ionic solution. Conductivity of ionic solution. So for this we have different cells. We have different cells that is called as conductivity cell. Now while measuring the conductivity, there are two different problems that arise. First one is if you pass a direct current, then it will change the composition of the solution. Okay. And second one, a solution cannot be connected directly to a bridge like metallic wire, okay, or any other solid conductor. It cannot be conducted directly, okay, because there may be any particular short circuit or anything. So there are two problems while measuring the conductivity. First one, if you pass a direct current DC, then what happens? The concentration or the complete composition of the solution will change. And secondly is the solution to of which you want to measure the conductivity, it cannot be directly connected to a Wheatstone bridge or any particular instrument in which we measure the conductivity. So how can we overcome this problem? First one, instead of using direct current, what we can use is use alternating current, that is AC, alternating current, okay, alternating current. So that will not change the composition of the solution. First problem is solved. Okay, that is also known as AC. And this is source of power, okay, AC as the alternating source of power. Then second one, second problem can be overcome. Instead of connecting it to a salt, any particular Wheatstone bridge or any other particular conductor to measure the conductivity, what we can design is we design a vessel, okay, and we design a vessel, and that vessel is called as conductivity cell. Conductivity cell. So in this conductivity cell, we can directly make the solution in contact with the instrument to which measures the conductivity. Now how it looks like. So there are two different types of conductivity cell. First one, let me just draw and show you people. So these are completely made up of glass. So this what I am drawing, it is completely made up of glass. And what we place here is the electrode, platinum electrodes. Platinum electrodes. So this is the electrode actually which I am drawing now. Okay. These are the two platinum electrodes, and these are further connected to wires. Okay, further connected to wires, which goes to a particular galvanometer which can measure the electric current. So these are further connecting wires which are further connected to galvanometer which conducts the electricity. So this is actually your platinum electrode. Now what is this? What is this which I have drawn here? This is nothing but platinized platinum electrode. This is nothing but platinized platinum electrode. Now what is the meaning of this? So here what we have is a small piece of powdered platinum such that it will increase the surface area and provide better results. Okay, so this is one type, and second type is in this form. Second type of conductivity cell, it is in this form. So here also we have two electrodes, and definitely on the bottom we have this platinized platinum electrode which increase the surface area and provide better results and better conductivity options. Okay, again these are the two platinum electrode, right, and these are the connecting wires. So these are the two different types of conductivity cells that are available for measurement of conductance or conductivity, okay, in any particular solution. Let me just see if any student has any comments or something. Okay. Good morning, Sudham. Thank you for joining. Very good morning, Bhagyashri, Prathamesh, and Mahalakshmi. Thank you for joining. Yeah. Now, as I said, basically it contains two platinum electrode, and at the tip of them there is powdered platinum, metallic platinum that is deposited. which increases the cross section area, and here we can say the cross section area is A, and length of this particular two electrodes that are separated, this length, okay, this I can take it as L. So just now we have seen resistance is rho into L upon A, and that can be also written as 1 upon Ka, correct? So these are the different terms that you need to remember, okay? Now here, cell constant is measured as a G star, okay? G star. G is conductance, G star is a cell constant, and it is given by G star is equals to L upon A. L upon A is nothing but your R and into K. Why K? Because L upon A is your R, right? And why K? Rho is there, right? Rho is there, and therefore inverse of that would be K. Inverse of that would be K. Now coming to Wheatstone bridge. Once the cell constant is determined, we can use it in measuring the resistance for conductivity of any particular solution. And how it is set up? It is set up by making use of any particular Wheatstone bridge. And what is a Wheatstone bridge? Probably you might have studied it in physics. Let me just draw it here. So this is your detector, which detects the flow of electricity. Okay. This is your resistance of conductivity cell, which is represented as R2. I can name this as R4. This is R1. This is R3. This is a Wheatstone bridge. This is your detector. In physics practically you have learned this, so probably you'll be knowing about it. So here R3 and R4, these are variable resistance, means you can vary them, and R1 is the variable resistance, which can be represented as with a upward arrow. This R3 and R4, these are two resistance. R1 is variable resistance, okay? So if you know three values, then you can measure the conductivity of the cell R2, right? If you know the resistance of this particular R2, then you can measure its conductivity, because conductivity and resistance, they are inversely proportional. So R2 is equals to R4 into R1, or else I can write R1 into R4 upon R3. These three values you will be knowing. This is R4 and R3. These are the two resistance of this particular Wheatstone bridge, and R1 you are varying it, so that value also you will be knowing. This R2 is a resistance of unknown particular solution, right? So if you know resistance, then definitely you can measure the conductance, right? Then again one more relation we have, that is conductivity is equals to cell constant upon R. Cell constant is represented as G star and resistance is represented as R. Okay, so based on this, there are many different formulas, right? There are many different formulas which we'll be seeing in the next class, right? So today we have just studied about the conductivity, resistance, and many other different terms. Okay. That's all for today's class. My next YouTube session will be on 20th of December 2020, and it will be at 9 a.m. and the topic that will be taken is the continuation part of this particular chapter, that is electrochemistry. Okay, so I request all of you to please go through the description box of this particular video and attend various classes that are present on Unacademy, and that's for your own benefit. Yeah. If you have any doubts, you can comment in the comment section. All of you. If you have any doubts, you can ask me. My next YouTube session will be on 20th of this particular month, and these are the different subscription plan. If you want to go for any subscription plan, you can just use this code PRKLIVE in order to get 10% off on any of the subscription plans. Okay, and you can refer your friends to attend the classes. The description of my video on Unacademy or my profile on Unacademy is given in the description box of this video, so you can use this code PRKLIVE to get 1 month subscription also of 2250. Okay, so I'm just waiting. If you have any doubts, you can comment in the comment section. All of you. Okay, so I think there's no doubt. So thank you so much everyone for joining the class. Please attend the next live session on 20th of this particular month at 9 a.m. Okay, thank you. Have a good day, and thank you so much for joining.